Good morning. My name is Pawel Skrzypek. Welcome to my presentation related to the review of the time series forecasting method, especially the latest one, the state-of-the-art one. A few words about me. I'm working as a Chief Technology Officer in the AI Investments, Polish startup. We are really focusing and working on the time series for almost 2 years. We have started at the beginning of the 2018 and we are focusing on the using time series forecasting to forecast financial time series. That's the reason that we have very well review of the available methods, and we are trying to stay up to date with the latest achievement in that area. On today's presentation, I would like to briefly review the most advanced time series forecasting methods. So we do not go to see how the LSTM or convolutional neural network are used in the time series forecast. I will show, I hope, some interesting methods which are not very popular but achieve very good results in the time series forecasting. And before that, a few words, what is time series? The simplest definition is that time series is just the ordered in time, the list of values of the given attribute. So it could be the price of the stock, the price of some goods. It could be the temperature, the rain level, and so on. And time series forecasting aims to forecast the future values of that time series. So we want to forecast next value. We want to forecast the values in the selected time horizon and so on. For the long time, the statistical method were used to do the time series forecasting. There are a lot of the methods. They work good for the certain time series with the certain characteristic, but for the most advanced, most difficult to predict with the high level of noise time series, the statistical method usually do not achieve good results. That's the reason that machine learning based time series forecasting methods were introduced. And that's a topic of my presentation, by the way, because the machine learning based time series were able to catch the nonlinear and more difficult to discover patterns within the time series, and of course, as you perfectly know, can learn from the data. The very crucial point in the time series forecasting was after the introducing the M4 competition. Before that, the time series was dominated by the statistical methods. Here we have the list of that methods that are the most popular one. Theta method and ensemble of the method is the probably most advanced currently statistical approach for the time series forecasting. But as I said, till the 2018, the statistical method dominated time series forecasting, but in the 2018, the results of the M4 competition has been announced, and M competition is very prestigious and probably one of the most recognizable competition in the time series forecasting. It is led by Professor Spyros Makridiakis from the University of Nicosia. He's a guru and even the legend in the time series forecasting, and the M4 was the fourth edition of this M competition. In the M4 competition, the goal was to predict 100,000 time series. So it's a very big very big number of the time series, and the winning method is proven that is robust and very well and achieve very very good results. The competition was won by the machine learning method, or so-called hybrid method, but it is mostly the machine learning. I will tell about that on the next slides. Also, the second method was based on the machine learning, so it shown that the machine learning become the dominant way of the time series forecasting, especially that the first method was better about 10 percentage point than the statistical methods. So for that number of the time series, 10% point of accuracy more was a very important achievement. Now the M5 was finished. The results are not yet officially announced, but we know that it was dominated by the machine learning method. So this was the really breakthrough. From that point, probably the machine learning methods are the fundamental approach for the time series forecasting. The first, the method which I want to briefly describe today is the ES hybrid method. It is the winning method from the M4 competition. I want to tell about that. It's quite old, over 2 years old, but it sets some kind of the standards. The very good paper was published by the author of the method. By the way, the method was invented by Polish guy Sławek Smyl. Sławek is working for Uber and now is working for Facebook. And Sławek published a paper in the Journal of Forecasting about his method. So we have very good knowledge. The source code is also available, but unfortunately in C++, but can be used, can be rewritten to Python if you prefer that language. The key innovation in that method was that first one is the data pre-processing exponential smoothing, which is nothing new, but new is that this data pre-processing is done in the same training loop as for the neural networks. So there is the one backpropagation process which train the neural networks and also train the weight of the exponential smoothing, the parameters of the exponential smoothing. So that's the first innovation. The second innovation is to use the LSTM, but not just simple LSTM neural network, but residual dilated and with attention. It was the first well-known usage of that residual dilated and with attention LSTMs for the time series forecasting. And there is also a very novel approach for the model ensembling. Some models are selected by time series. The set of the model is trained on the big number of the time series, like 1100, and best models are selected for the subsets of the time series. So it's a very complex approach for the ensembling, and that's the one of the key success of that method. For the more details, I recommend to read that paper and to go through the source code of that method. How we are using that method? Maybe before how we are using the advanced architecture of the LSTM or innovate architecture of that LSTM is that the first one is deletion. So it is the concept borrowed from the convolutional neural network. So each of the layer have a different deletion. So first layer get the 1 value, then next the 8 value, and so on of the time series. The next layer goes with the deletion of 4, and so on. So in that case, the network can see bigger area of the time series. And the second concept also borrow from the convolutional neural network is the residual connections. So to the next layer is the both past the input from the previous layer. So as we can see here, yeah, to the third layer goes input from the second layer, but also the input from the previous layer is attached. So this is this this residual connection, very similar to the convolutional neural network. And also we have two linear adapters at the output of the network for the different frequency of the time series. So different architecture was used for the different frequency of the data for monthly, quarterly, yearly, and so on. And how we are using that? We are able, using that method, to predict certain number of the future values of the time series with the quite good accuracy. So if we are here, we are able to predict up to 24 next values of the time series. Just that simple, but the key is the achieved accuracy. Next method, which I want to describe very briefly, is Facebook Prophet. It's a statistical method, but with some interesting elements, because it's a combination of the statistical method based on the Gaussian mixture models. It is very easy to use. Yeah, Facebook provide the whole library. It's very easy to start using that. And why I put that method? Because it is possible also to use that with the continuous optimization and sampling approach. And sampling can be done by the training the neural network to choose which models, which Facebook Prophets models can be used to predict the data. So we are using Facebook Prophet by the training many models with different parameters, and then use the neural network to choose which models should be used for the given particular forecasting. Very interesting feature of the Facebook Prophet is that we can predict the not only the certain value, but also the upper and lower confidence band. And thanks to that, we are able to determine the range of the future values. Next method is the Gluon. Sorry for that, but just move that way. GluonTS, it is the library by Google, described in that paper here. And this is the complete framework, probably the most used one, a complete framework for the time series forecasting. It includes various machine learning methods and algorithms, and is constructed in a very interesting way. I will show that on the next slide. And it has a very strong community support, and also it is supported by the cloud computing providers, both on the GCP and AWS. And that's the very interesting construction of that, yeah, because we have a different solution, different way of the time series forecasting, and each of that way or the models covers different type of the neural networks, probabilistic components, structures, and probabilistic distribution. Yeah. For example, Gluon TS also includes the latest transformer based neural network architectures. So it is possible to also very easy start to experiment with that library and to make a time series prediction using the really advanced model, and also to experiment with the different combination of the neural networks, structures, probabilistic estimation, and probabilistic distribution for that. Next method is a method called NBITS. It's very interesting that the co-author of that method is one of the fathers of the machine learning, Joshua Bengio. In this paper, as you can see below, they claims that they have better results than as hybrid method by Sławek on the M4 dataset. And this method is a fully machine learning. It has the unique architecture based on the stack and blocks. There are different type of the stacks for the trend, seasonality, and generic. Also, there are some elements of the explainability, so we can explain the prediction and the transfer learning features. Also, NBITS is using the advanced models assembling, even more advanced than the Sławek's as hybrid methods, and ensemble up, as far as I remember, up to 150 models for the time series forecasting. So it's quite a lot. And how it works. Yeah, the basic block is the 4 layers stack. It is fully connected, just simple dense neural network. But from that stack, these 4 layers, we have 2 outputs. One output is forecast of that stack, and the second output is so-called backcast. And the backcast from one block is passed to the another block. Also, there is a residual connection. So to the next block goes output from the first block, and also the input from the original input to the first block. This is passed to the second block, but also from each block we have the forecasted output, and this forecasted output from all of the blocks is connected into the sum of the forecast. So the forecast is the sum of the outputs from each block. This is the forecast from the stack, and we have the similar solution for the global forecast, global output. It is the sum of the forecast from the stack, and the results of the forecast from one stack is the results of the backcast from the one stack is just passed to the second value. The next method, quite a different one than previously presented, is so-called settling machine. Settling machine is based on the algorithm called stochastic learning automata. It is the long-known algorithm invented by the Russian scientist Setlin, and this method is used also to the time series forecasting, but not only. It is also used for the reinforcement learning and other this type of the application. It is very popular in the reinforcement learning, maybe not as popular as the leading algorithm like DQN or actor critics, but its main feature is ability to create the distribution and manage the probabilistic distribution. And also this feature is used for the time series forecasting together with the advanced models and sampling. The method is described in this paper, as you can see below. The Norway data scientists are currently doing great work on research on that method. It is probably the strongest researcher team which works on that method and also receives very good results. We have used that method for the time series forecasting, and it is especially important especially useful for the difficult to predict time series, like the financial time series with the high level of noise, no stationarity, and with the heteroscedasticity. And how it works, yeah. For each parameter, for each input parameters, in terms of the time series, we have the time series as the input with the certain history length, like 20 last values, and for each parameter is created the stochastic distribution, and parameters of these distributions are learned in the training process. So the stochastic learning automata in fact learns the probability distribution from the data, and this probability distribution could be adjusted. So we could learn that in the supervised way and then adjust with each prediction, and after the prediction, when we have the real value, we can compare real value in the same way as in the supervised stochastic backpropagation process and adjust the probability distribution. So as the opposition for the, let's say, more typical methods, these methods can learn from data also in the reinforcement learning way, so could learn live and update the probabilistic distribution. Also very important is that we could combine these settling machines with the different inputs. Yeah, so there could be also included additional data to the time series, explanatory data, and for them also can be created the probabilistic stochastic distribution, which are used to predict the value. As we can see, we probabilistic distribution for each parameters, and the sum, the forecasted results is just the sum of the forecasting by each parameters. The settling machines could be also combined with the neural networks. So instead, just from the summing it up, we could use the neural networks. Also, we can use the neural networks with attention, like transformer-based architecture, which can also achieve very good results here, because the attention allows us to focus on the certain part of the time series and to improve the accuracy of the prediction that way. That's all about the methods. Just a very brief summary. On my presentation, I wanted to present the latest achievements, the not very well known methods, but each of the methods achieve very good accuracy in terms of the time series predictions. Of course, the development of the time series method is still ongoing. We are currently evaluating more advanced method. So maybe for the next year's summit, I will be able to update my presentation with the latest achievements in that area. So stay tuned for that. And yeah, as I said, the efficiency of the forecasting of the machine learning method is significantly higher than the statistical methods, especially for the difficult to predict time series. Yeah, as the name of our company says, we are focusing on the using machine learning for the investing. So we need to predict financial time series, which are very difficult to predict because they are with the high level of noise, with the non-stationality, heteroscedasticity, and so on. So it is very difficult, but with the presented method, we can achieve the 60% of accuracy for the longer term prediction. But of course, time series is applicable not only to the financial and investments, but to the many areas. Like the topic of the M5 was to predict the sales in the retail stores. Also, it could be used for the prediction of the health values like EKG and other parameters, health related parameters, to predict the weather, to predict many things. So if you are interested in that area, I hope you find this presentation useful. This presentation is available, so you could check the references to the paper and experiments with that method. Thank you very much for participating in my presentation. I really hope that you will find it somehow useful. Yeah, thank you very much.